Okay, this is the second day for take one. Make sure you know your take one with me will be on Monday and Wednesday. Okay, on Tuesday and Thursday you will be on midterm. Okay, but Tuesday and Thursday will be on Mr. Thai. That's for the lab. Yesterday, you guys already learned how to working with the simulation MSIM7. Okay, try to understand how to do what to do. That will be very good. Okay, to do with the real lab if you know how to do simulation. We get next week to Monday and Wednesday will be on DC, and after that will be in electronic. Okay, no more DC. So last time we already talking about law. Make sure you understand.
This is what I'm listening to.
You mute the mics, please, Mr. Fran.
Yeah. Okay, the relation between the voltage and the current and resistor, that's what we're talking about, the Ohm's laws. E equal I times R. That means the voltage equal the current times resistor, or if you want the current will be E divided to R. Or if you want the resistor, they will be E divided to I. However, the important thing in this formula is the voltage have to be in volt. I, the current must be in ampere, and resistor have to be in ohm. If it's not, then you might have to make the change. Okay, and also this is a three formula to calculate the power. Even the simulation or in the real lab, we cannot measure the power. Volt DMM, voltmeter cannot measure the power. If we want to measure the power, we need a power meter. That's what we already ordered, but it's not coming yet. Okay, in order to calculate the power, P equal V times I, voltage times the current, or you can using formula I square over R, or V square over R. Unit of the power will be a watt, kilowatt, milliwatt, okay, whatever. Today we start with what we call a series circuitry. You get two different types of the circuit in the series in the DC. That will be a series and parallel circuit, okay? And today we're talking about series first. The current is the same everywhere in the circuit. The total resistance equal to the sum of the individual resistance. The total voltage is equal to the sum of the voltage drop across each individual resistance. That's only telling you the voltage in the series circuitry, they're not the same. They will be different, okay? And the total power equal to the sum of the power dissipated by each resistor. Okay, now you go see this is the series circuitry. Okay, how come we know the series? And you can see you can get only one current from coming from the power. Okay, they go through the same through each resistor. That means in the series circuitry, you get only one path for the current flow. Current I go to R1, R2, R3 will be the same. Okay? And now, first thing you need to recognize this is the series circuit by looking into the current. If they get the same current, they will be connected in series. Okay? And now you can see the current when they go to the resistor. Okay? And when they're coming in positive, they leaving the negative. Okay? Coming in positive, leaving negative, and keep going. Okay? So sometimes they can asking you, the question is you get a resistor here. A, B. They asking you which side of that resistor will be positive. Which side? Like you interview, they given you resistor, tell me which one is positive, A or B.
A.
Depends on your battery.
It depends on which direction the current is flowing.
The answer will be resistor have a no polarity. Okay? They don't have any polarity. However, when you connect to the circuit to get the current flow, then the current coming in, that will be positive. Current leaving will be negative. Okay? So make sure you understand that. Resistor have a no polarity. Okay? Depend on if the current coming in, that will be positive. And leaving, they will be negative. So that's why when you're using the meter to measure resistance, you don't care, you know, the high side or low side connect to where? You connect to both sides. High or low, that doesn't matter. It's still working. The thing is they don't have a clarity, okay? Now, current in the same through each resistor. Voltage across each resistor different. Power dissipate each resistor different. Total resistance. That means if you want to calculate the total resistance for the series circuitry, just add them up. For example, you get 2 ohm adding to 6 ohm, 8 ohm adding to 4, you get 12 ohm. That's the total. That's very simple. Okay? And now, if you want the voltage, okay, for example, if you want the voltage at A, so we're talking about two things. One will be called a single point. I say point A. How many volts? How many volts
24.
on that point A?
24.
24. Okay, now, if I given you the meter, diameter, you get the positive, negative on the diameter. If I want to measure at the point A, how do I connect?
The bread on the positive.
Positive will be connected to
Bread.
A. How about negative of the meter?
Connect to
D.
D.
E.
D.
Ground.
D.
Connect to the ground. You see that?
Yeah.
So basically, when you measure the voltage, okay, make sure if they say, okay, I want the voltage at the point A, then the high side of the meter must be A and the low side must be to common. That means to the right. So either the same thing, point A or point B or point C, whatever point, okay? Single point. So now the other thing, I say I want to measure VR1 here. VR1, what that mean?
So the one that drop after
Voltage
the passing
resistor one.
R1.
That means the voltage drop
Yeah.
across the
The R1.
R1. Okay, that means the voltage drop around here. Okay, so now if I say VR1 basically from A to the point B, okay, that means from A to B. You can see I say VA to B, VAB. Now, anytime if you say VAB means VA minus VB. Okay. If VCD, same thing. That means the VC minus VD. Okay. VA minus VB, that's telling you the voltage at A will be higher than the voltage at B. Okay. So now if I want to measure the voltage at B, how can we do?
So
I want voltage here. How do we connect DMM?
we connect the positive to B and negative to ground.
DMM.
Yeah, connect the positive lead to A
To
and the negative
A.
lead to B.
Okay. High to A. And low
B.
to B. You can see the difference. When you say you want the voltage from A to B, you're using your meter. Then the high side of your meter will be connected to A, and the low side must be connected to B. The low side only connect to the ground when you measure the single point only. So you understand now?
Yeah.
Okay. So that's why I say voltage across resistor R1, VR1 will be equal current I times R1. That's Ohm's law. If you want the VR2 voltage dissipate, R2 will be I times R2. And the same for VR3. Okay. And if you calculate the power dissipate on R1, then PR1 equal I square times R1. For R2 will be I square times R2. And R3 I square times R3. Okay. So now what I want you to do, complete that table for me. For the circuit shown for total resistance, total current, and the voltage VR1, VR2, VR3. Quickly try to do it. Tell me what to get.
You've covered up the resistance of R1.
R1.
Sorry, but we can't see the resistance of R1 value anymore.
It's 2. So the
Okay,
total's
you
12.
cannot see the resistor R1. 2 ohm.
12.
Yeah, resistance is 12.
Okay, that's good.
So the current is 2 amps,
2A.
24 divided by 12. So the power in R1 is 2 amps squared times 2. So that's 4 times 2, 8 watts.
Yeah, just a minute. So now you say 12 ohm. Right?
Yeah,
Current will be
2.
2 amp. That's for the other student. They can recording the answer. If you don't know why, how, just let me know. VR1
4.
4. 4.
or volt,
4.
4.
okay? VR2
12.
12.
12.
VR3
8.
okay? Power PR1
A.
8.
8.
what number?
8.
8. 8.
8 watt? PR2
24.
24.
Yeah.
Last one
12.
16.
16.
16, not 12.
okay.
16.
Oh, okay.
16.
16. Sorry.
What you say? 16 or 50?
16.
16.
1
16.
6. 1 6.
6.
Yes, everyone.
Okay, make sure everyone you get that answer, okay?
I don't understand anything of what you just did.
You mean you don't understand anything?
Where these calculations results came from.
Okay, you get 1, 2, 3, 4, 5, 6, number 8. Quick calculation. Do not follow it. Which one?
I think he's got a problem with Ohm's law.
No. I want to asking from question number 1 up to number 8. Quick question. You don't know.
Do number 1.
From-
Number 1. Okay.
Yeah, done.
Now, I already said in here. Okay. Total resistance equal R1 plus R2 plus R3 plus more if you get more. So now you get 2 ohm adding 6 ohm adding 4 ohm, you get 12 ohm. What can I do better?
I think the secret here is understanding that the current in the circuit is the applied voltage
Okay,
divided
that means number
by
2. You want to calculate the current. Okay, the current will be I equal E divided to R total.
Yeah.
So that's 24
By 12.
divide 12. That's what you get to.
2.
Basically, we already given to you on of the formula here. Okay. You see that the formula here. Whatever you want to do, calculate it, substitute the value into the formula.
How did we get VR1, VR2, and VR3?
How come you get
VR1, which is question
what is PR1?
5.
PR1 means the power dissipate through R1.
Or voltage drop.
Item one.
Yeah,
I think
VR1
he's
is,
I think he's asking how we got the number, which is he just need to look at the chart on the top where it says R1, R2, R3. That's where he got the number from.
How come we get R1?
Just remember that the voltage starts at 24 volts and each resistor subtracts a certain amount of voltage from 24 volts. So if R1 has 24 volts flowing through it, it will subtract or have a voltage drop from 24 volts. So after resistor 1, you're going to have a difference in the 24 volts. That's why you have 4 for VR1. There's a voltage drop. So at B, you're going to have 20 volts.
Right,
So
because it's going into the resistance, right? The resistance, the first one, the resistance one.
each resistor subtracts from the 24 volts, then sends the remainder of the voltage to the next resistor. So when you start from R1 to R2 to R3, at the end of R3, you're going to have 0 volts.
that's an example. What was just explained is called Kirchhoff's voltage law, which means that the sum of the voltage drops around a series circuit is equal to the applied voltage. So that by the time you get to point D, the voltage is 0. So you've got 24 volts applied. And if you take the voltage drop across R1 plus the voltage drop across R2 and the voltage drop across R3, it must equal the applied voltage.
Okay.
And the
So going through the first resistor, it's going to get 12. Is that for number 1?
Hear me.
So if it's going for 24 volts through the first resistor, we're going to get 12 ohms, right?
The voltage drop through the first resistor is 4 volts. After R1, you have 20 volts remaining.
Oh, so it's dropping by 4.
Correct. Resistor R1 takes 4 volts and then sends the remaining voltage to R2.
2, right? Okay.
How are
So
you
the
getting
vo-
4 volts?
Okay,
Because R1 has 2.
Two
Okay.
ohms.
R1
So-
subtracts 4 volts from 24 volts from E, where E starts. You have
But where-
R1
4.
R1 is the very first resistor. So your first total is 24 volts. So after it hits the first resistor, it's going to take 4 volts off, leaving you with 20 volts.
correct.
I
No,
guess
I
the-
understand what you're saying, but I'm trying to see where you're getting number 4, because if it's 24 volts and the first resistor is 2, 24 minus 2 is 22.
You have your first resistor, right, at 2
Yes.
ohms. And
Yeah.
you need to find first the total current, I, which is 2 amps, right? And that is 24 volts, right? Okay, so yeah, 2 amps. And then you multiply the 2 amps times the 2 ohms, and then you get 2 volts. So VR2,
No.
you are
Oh, okay. So you
total
find an
current,
amp first.
2 amps times 6 ohms, you get 12 volts. For
Okay.
VR3, you have, once again, 2 amps times 4, you get 8 volts. So it just the math.
Can you repeat how you got that, the 2 amps?
Can I just jump in real quick? Okay, the main thing is when you're approaching these series circuits like this, the very first thing you want to do is look at the circuit. Look at what you got for resistance and look at what you have for voltage. Then what you want to do is find the total resistance first. The voltage is given. The total voltage is E equals 24. That's given. So find the total resistance first. Once you find the total resistance, the total current is I is equal to E over R. So then you find it. Once you find the current in a series circuit is the same. So multiply the current times each resistor and you'll get the voltage drop across each resistor.
So once again, I equals E over R total. And that's how you get your I, the 2 amps.
Exactly, that's what I said. exactly.
Just regurgitating, simplifying.
Okay.
Yeah, right.
And E total is equal to, the R total is equal to the sum of the resistances in the series loop.
Exactly, exactly. So what you do here, you look at the circuit and you say R1 is 2 ohms. Okay, then R2 is 6 ohms. So 2 and 6 is 8. R3 is 4 ohms. 8 and 4 is 12. So R total is equal to 12. Now you need to find the current. That's the second thing. I is equal to E over R. So then you put, you divide 24 by 12. When you divide 24 by 12, you get 2. So 2 is the total current.
Amps.
That is, yeah, the total current in amps going in the circuit, in the series circuit. Because in series circuit, the current is the same over each resistor. So then you
Because it has no place else to go.
right. You have you multiply the current times R1. So R1 is 2 ohms. The current is 2 amps. So 2 times 2 is 4. That's why the current, is 4 volts over R1. VR1 is 4. Then you multiply the total current, which is 2 times 6 ohms. 2 times 6 is 12. That's why you have 12 volts over R2. And then you multiply 2 amps times R4 and you get 8. And if you add up all those voltage drops, they should equal 24. Did everybody get that?
Thank you.
Another thing, Joe, is for every student, look at Ohm's law chart, bring up Ohm's law and look at that pie chart. The pie chart will help you with the math.
The key formula you want to remember in electronics, whether if you're doing AC or DC or whatever, the key formula that comes up through all of this is going to be V is equal to I times R. V and E is the same thing, is equal to I times R. And what you do is you flip-flop that formula around. V is equal to I times R, I is equal to V over R, and R is equal to V over I. And a lot of this also has to do with how much math some of you guys have had.
So what's number 6?
Number 6 is I squared R. So I squared, I is 2, and 2 squared is 4. So then 4 times R1 is, that's 8.
2, so 8. And you just follow the same through 7 and 8.
Right, yeah, because the formula is power is equal to I squared R, or power is equal to E times I, or power is equal to V squared over R. In this case, we know what I is, so we square I. Well, I is 2. 2 squared is 4. And then so 4 times the resistance will give you the power over that resistance. Then you go to the next one. 4 times 6 is 24. 4 times 4 is 16. That's how we got all those answers.
Thank
And
you.
you can double check your work by doing the calculation. The total resistance is 12. That means there's I is equal to 2 amps because it's 24 over 12. So the total power is I squared 4 times 12, which is 48. And if you add up PR1, PR2, and PR3, it's 48.
Okay, any more questions on this problem?
For the person that answered, did that answer your question?
Perfectly. Perfectly. Thank you very much.
Okay, now we go to the voltage divider rules. What that mean? That will be telling you, if you want to calculate the voltage at point B, you can see right here. That means I1 VB. If you're using the meter to measure, then the high side connect to B, and the low side of the meter must be connected to common, mean the route. However, now If you want to calculate the voltage at B, that means at the point B to the route. Normally, this is a series circuitry. And you get only 2 resistors, 2 kilo ohm, and 8 kilo ohm. So you can calculate the R total. What R total equal? Is it 10K, right?
Right.
You're adding 2K to 8K. Okay? Now, if you get the total resistance, you're able to calculate the total current. That's what we did like previous one. I total equal E divide R total. That means 10 volt divide 10K. What you think you get?
1.
10
what?
milliamps. 1 milliamp.
They must be 1
milli. 1 milli.
amp, not amp. The thing is you divide to kilo ohm. Kilo ohm means 1,000 ohm. I don't want you converting times 10 minus 3, okay, power of 3. So automatically when you divide voltage to the kilo ohm, you must get milliamp. Okay? And now, after you get the current I equal 1 milliamp, so VB calculation equal what? Tell me the formula. VB equal
8.
Two million, 2 ohm.
No, the formula first. V from B to route.
Yeah.
VA minus
I time
RI.
I time R2, R1.
Now, VB, you can see if you get the VAB, I don't care what happened. I know VA minus VB, right?
2 volts.
Okay. However, VB means from B
2 volt.
to
2
route.
volt.
That means equal I times what?
I time R2, R1,
R2.
R2.
That means from here to the route. That means the voltage across the R2. Okay. That will be telling you 1 milliamp time R2 will be 8K. So you will be get 8 volt. Is it correct?
Yes.
No, it's VAB. VAB is
No.
8 volt.
Find the easy way to do first. I said
Yeah.
VB means from B to the route. That means the voltage across the R2.
R2, yeah.
So you just take I times R2. You already know I.
Yeah.
You know R2 is 8K. That's why I get VB equal 8 volt.
And also too, Mr. Pham, I noticed, which was good, you utilized the exponentials like you told us the other day. You multiply 1 times 8 is 8, and then the milliamp and the K will cancel each other out.
Right. The thing one will be times 10 minus 3. Another one will be times 10 power 3. They cancel out. So VB will be 8 volt. Now, if you say VB on the formula VAB equal VA minus VB, okay? And the VA will be 10 volt.
10 volt.
Okay? VB, you cannot calculate it. That will be helping you to calculate the VR1. So, I bring it up here to make sure you understand it. You want to calculate the voltage at the point B. You need to know what is the current I. You have to calculate the current I. You have to calculate the total resistance. Okay? After you get the current, you multiply by R2. That means you get a VB. Okay, now we go with what the voltage divider. The voltage divider, they will be helping you. You don't have to calculate too many things. Okay? I go through that for you. Now, in order to calculate the voltage divider FB, VB equal to the E time any voltage from B to the ground. That means R2. And you divide total R1 plus R2. That one formula. And you can get the same answer. Without calculate the total resistance and calculate the current. Okay. Now we go to another circuitry. Okay. And I try to explain to you. So you will be doing the calculation. Okay, on this circuitry here, they say they want to calculate the voltage at B. They want voltage here. Now, using the voltage divider, VB equal who can tell me what the formula? VB measured from B to the ground, you will be measured through R2, R3, and R4. Okay, so VB will be 13 E times what?
R1.
R2, R3,
R4.
R4.
Perfect. Everything divide
Everything, yeah.
Right.
R1,
R1, R2,
R2,
2.5.
R3, R4.
R4. That is the voltage divider. Instead, you have to calculate the total resistor. Then you have to calculate the current I. Then you can multiply to get the VR2, VR3, VR4, add them up. That take a long. So we can using this voltage divider law. Okay, now if I want, make sure you understand, I want VC right here. Equal what? Equal formula.
R3 plus R4.
Time
what? R3.
R3 plus R4 plus R4 divided total.
Right. Okay?
Yeah.
So now if you want the VA right here, then they will be E times what?
Times R4.
Divided by total.
Divided total.
Okay, perfect. Now do your calculation so we can get the answer for everyone. If you done it, let me know what your answer.
VB is 8 volts.
So the VB is 160.
16.
16. 16 volt.
No, the VB, not the VC.
V at point B
is 16.
16 volt. Is it right?
Yes.
Right.
Okay, then point C. Who get the answer for point C?
14. 14.
You get the total voltage.
14.
14.
Okay,
14.
the total voltage only 20 volt. If you say 16 volt, you're adding 14, you get more than 20. Cannot.
14 at C.
You say 14?
Yes.
Wrong. This is 16, this is 14. 14, you adding up, you higher than 20 volt. Cannot. Must be some wrong, either one.
Okay.
Mr. Tai, I think it's a voltage at point C, not the voltage across resistor.
So VC with respect to ground, I think so it's 14 volts.
14,
Yeah. Respect
with
ground.
to ground.
From here to here.
Yeah.
Okay, you
That
get
can be
14.
correct. That can be 14.
Okay, now
You don't have
what
to add
happened
here.
to point B? What happened to B?
Point B is 16.
You add, okay, you said 20.
Mr. Pham, if we add VR1 plus VR2 plus VR3 plus VR4, then it should not be greater than 20 volt. That's correct.
Correct.
But if you measure VC with respect to ground, it can be 14 volts.
That's okay. So VB, what did we get last time? 16, right?
B16, C14.
A.
8 volts.
A is 8.
Okay.
The total,
That doesn't matter. That's
Yeah.
a single point. Not voltage across resistor. That means if you calculate the VR1, VR2, VR3, VR4, adding up, they must be 20.
yeah.
Okay, so that's why I'm telling you. Voltage divider law will helping you to make a shortcut. Instead, you have to calculate the total resistance. Then you have to calculate the current. Okay. Then you have to using Ohm law to calculate the VB, VC or V. Okay.
Explaining and they're saying, can we have a study group?
Richard, please mute yourself. We can hear your conversation.
Okay, so what the hell?
The floor instructor though.
You get any question about this
No,
problem?
I mean, poor guy.
Mr. Pham, mute that person's mic.
His fault.
Okay, you get any question on this voltage divider law?
If they have a problem, the total resistance was 500 and the total current was 40 milliamps. They can figure it out that way and then backtrack and do the voltage divider.
Yeah, either way. However, the other way take a little longer.
We could get Faustat going.
Okay, now we go to the next one. Parallel circuit. You understand the voltage divider apply only to the series circuitry, not parallel. Now, voltage is the same across each branch of the circuit. Total current equals the sum of individual branch current. The equivalent resistance is less than the smallest branch resistance. Total power equals sum of power dissipated on each resistance. Now you can see this is the parallel circuit. Okay. On this one, you get the power here, and R1, R2, Rn anymore. Resistor connect in parallel. First thing, voltage across each resistor will be the same thing. You can see easy, right? They treat the same E. However, when the total current here go to the first branch, they go I1 and the next I2 and keep so on, okay? More resistor in parallel, they get more branch current. Okay, all the resistor connected in parallel have the same voltage. Okay, E equals VR1, VR2, or VRn. The current through each resistor, they call a branch current, in parallel will be different. However, I total here will be equal I1 plus I2 and so on. Total resistance are total, or they call a equivalent resistance. Calculate as following. That means if you want to calculate the total resistance, you combine R1, R2, Rn into only one resistor. This, you have to using this formula. R total equals 1 divide to 1 over R1 plus 1 over R2 and the plus 1 over Rn. Okay. For only resistor in parallel, you can using this formula. R total equals R1 times R2 divide to R1 plus R2. That only apply to two resistors. Okay. Now you can see this circuitry here. So I want to calculate the R total here. You do your calculation to see you can get 3 ohm or not. Do that first. That means you must be using the formula. Okay. R total equal 1 over R1. Go ahead and try to see. I already get the answer here. Make sure that answer will be correct.
You can also do a little trick here. 9 ohms is 2 18 ohm resistors in parallel, and 6 ohms is 3 18 ohm resistors in parallel. So it's like 6 18 ohm resistors in parallel. Yeah. So
you
simply
can do
becomes
this way.
18 over 6, which is 3.
Yeah. Some people in Simaca, they say they're doing R2, R3 parallel, right? And you're using R2 times R3 divided R2 plus R3, right? Then that answer will be parallel with R1. That means you don't want to using the full formula. But either way, still working. Make sure you can get 3 ohm.
Yes, 3 ohm.
Okay, that's good. If you're done on that one, then you try a next example for me. I get 8 ohm.
Yeah, 8 ohms is right.
Okay, that's good. The thing is basically in a practical, you don't have to do it, right? The thing is, you want it, you can using the meter to measure. And in the view, they just asking for only 2 resistors in parallel. They make it simple as much to see that people know in the basic how to do calculation. Not try to give in a big circuitry, take a long time.
Also, too, Mr. Pham, like you said, right off the bat, you know that in parallel, your answer is going to be smaller than the smallest resistor.
Perfect. That's what we said it in the handout.
Mm-hmm.
That's a good hint for taking quizzes and tests. If any answer is larger than the smallest resistor, then that's a wrong answer.
Correct.
Just go by the handout few times or more. You don't have to read any different textbook. That good enough to be a technician.
One other practical suggestion is if you're measuring resistance, make sure the circuit is disconnected from any power source.
Perfect.
Or you'll blow
Yeah,
up
you
your
know.
meter.
You already know. When we up to that point, then we'll be telling you. When you want to measure resistance, you must be disconnect the power. And I will be telling you how meter can measure the resistance. Okay? When you understand that, then why we need to disconnect the power. Okay, so otherwise we have 3 ohm and we get 8 ohm. If you cannot finish that, give the record the answer. Okay, do it when you get a time. Okay, now quickly get through that one for me. One, I given you 50. If you can do this thing, okay, that's the answer I already give you. 50. Next time I will be upload by PDF. By PowerPoint, they don't recognize the symbol ohm.
Yeah, this is correct because 2 equal resistors in parallel is equal to half of the resistance of each individual resistor. So 200 plus 200 in parallel is 100.
Right.
And the other 200 plus 200 in parallel is 100. And 2 100 ohm resistors in parallel is 50.
Yeah, perfect. You'll be a technician. Interview, no big deal. You take 200 in parallel. The answer will be 100, right?
Yes.
This one, 200, same value. How to know the resistance equivalent will be 100. And this one, another 100. Okay, then 100 parallel 100, you get a half, 50 ohm. Don't need to do any calculation. Make sure on of the lecture will be recorded, okay? And next day will be on the YouTube. You can watch again if you want it.
The answer is 196 kilo ohm.
Total equal what number?
Yeah, I agree. 1.96 kilo ohms.
Is it 1.96?
Yes, it is. Yes, this sir.
Needed a calculator for that one.
Yes, correct. 196 kilo ohm.
196, not 1. How come you get 196? You get 28 and 2K, they're supposed to be less, right?
Yes, correct.
The smallest resistor is 2K, and the total is 1.96, which is less than 2K.
Okay, so now you get 8 times 2. 98 plus 2.
So 1/98K is 10.2 times 10 to the minus 6.
Yeah, 1.96K.
Okay. And 1/2K is 500 times 10 to the minus 6 plus is 510 times 10 to the minus 6. Reciprocal is 1.96K.
Okay. So, if you're
Hello.
not done yet,
Good night. Thank you.
you're not done yet, copy the answer. Okay. Next one will be a current divider law. In the series circuitry, you get the voltage divider law. The thing is, the voltage different in the series circuit. In the parallel circuitry, the voltage will be the same.
Hello. Good night.
So that's why you need a current divider. In order to calculate the current divider law, this is the formula. If you want I1, then you could take the total current times R2, divide R1 plus R2. This is an example for you. Okay? If you want I2, then you take the total current times R1, divide R1 plus R2. That's what the current divider law. Current divider law apply to parallel, the thing in parallel, the current different in each branch.
Hey, Mr. Pham, you said the opposite resistor, right?
Right.
Mhm.
So, Mr. Pham, got a question. Current divider law only work for 2 resistors. Anything more than 2 does not work, correct?
Exactly.
Okay, thank you.
Oh, I'm not sure that's true.
That's what we say apply for only 2 resistors in parallel.
Oh, you're correct. Yeah.
Yeah, make sure
But-
you know, everyone try to read the handout. We cover everything for you guys.
I think this law is the least intuitive of all the laws we've learned tonight. But think about if R2 is infinite in open circuit, then all the current will go through R1. So this formula is the larger R2 is, the more current goes through R1, or the larger R1 is, the more current goes through R2, and that's what these formulas represent. So.
But normally you can see easy to recognize. When you get a voltage, then you just divide to the resistor to get current. That's it. Right? The voltage will be the same.
Exactly, yeah. And if you do have more than 2 resistors, then you can just
Yeah.
calculate the current through each resistor individually as the applied voltage divided by the resistance.
Just take a voltage divide to different resistor to get different current. Easy way.
Exactly. Yes, yes.
Resistance is the opposition to current flow, so current is going to take the path of least resistance.
Exactly.
Okay, quickly get through that one here. However, on that one, I already given you the answer. Okay, so we don't want to waste more time on that thing. Now, they given you this circuitry with the 36 volt. R1 2K, R2 8K. They want the total. So basically, you're using R1 times R2 divide R1 plus R2. So that's why you get 1.6K. Okay. Then, if you want to calculate the total current, now, this I want to bring it up here. You get R total. So you don't need that circuitry. Now you can get into this circuitry like this one here. That will be plus 36 volt. And this resistor will be R total. You get 1.6K. So now if you want to get the current I, then I will be equal 36 volt divide 1.6K. Given to you 22.5. Must be milliamp. Okay? So when you combine R1, R2, then you get R total. So the current I here will be the I total. Okay? And in this one, they want to calculate the P total. P total. Total power equal V times I total. V here will be 36. I total we just calculated will be 22.5 milliamp. Okay. 22.5 milliamp. You must be times 10 power of 3 to get the amp. Okay. The answer will be 810 milliwatt. When you calculate, you get the watt, you want milliwatt, you multiply by 1,000. And then if you want to calculate the IQ, they're using a voltage divider. However, easy one, you can get 36 volt here. And you get resistor here. You can easy to calculate the current IQ. 36 divided 8. Same thing for I1. Okay, now I will be stop the lecture at this point. You will be get to doing the quiz. Okay, I run the quiz and try to see how much you can get. Only make sure you understand it. Last time we run number query number 1, and now we will be try to run for number 2.
You share your screen.
We don't see
Yeah.
anything.
You see anything?
Nothing.
Okay, so that means I forget to share. Okay, share that first.
Okay, look like it's. Okay, it's on.
So how do we actually enter our answers?
I don't know the answer yet. You have to mark it on your. So when we review, you know you get the right or wrong.
Right in
All
on
right,
sheet
so
of
it's
paper.
1/8 times 10 to the 3, which is 18K. All right, so B.
I don't know.
Just write it on your sheet of paper.
Yeah. Let's try to see how much you can get the right answer.
Oh, okay. So I just gave the answer to everyone. Sorry, I'll shut up.
Yeah, so thank you, Richard. A freebie.
This is a test. This is a test.
You can enable your edit too as well and write in your answer.
This is only a test.
Yeah, you can enable your file and circle A or B or C or D. If you don't know anything, select D.
What was that? Select B.
Well, I gave away the answer. Sorry.
The thing is, Chris, let's try to make sure you're able to handle, okay? That means whatever we already given out to you, you understand. So we're going faster or slower, depend how many people can get through it.
Hey, while people are thinking about this, I just harkened back to an old mnemonic for remembering the resistor code, which is bad booze rots our young guts, but vodka does well. Vodka goes well.
Good one.
It used to be a little bit racier, but.
Oh, yeah, it's still out there. There is an R-rated version.
I learned it when I was 12 years old, trying to study for the my ham radio license.
Now you're aging yourself.
Nice.
It's also easy to remember that it's basically just black, brown, and then the colors of the rainbow. So red, orange, yellow, green, blue. Most people learned that in like elementary school. So
And then follow, yeah, it's Roy G. Biv without the I, and then so black, brown, Roy G. Biv without the I, and then gray, white.
Mhm.
So it's brown to black to gray to
And
white
then
with
gold,
the
silver.
yeah.
Ladies and gentlemen, this is a test. You're not supposed to help your neighbor.
Hey, we're a village. And the answers are given on the slide. Next question.
That I still get a problem with it. Timing. That's what I given to you, the table. Easy for you to do.
We can't see the entire slide.
Did you know they already changed the name for this program? That means before they get a San Diego Community College continuing education, now they can to San Diego Community College of Continuing Education. So they try to bring it up like the same as in the city college.
Okay, I asked in the chat, but I'm just going to ask here, and if this is a dumb question, fine. Are we turning this in? Are we
No.
just doing this for ourselves?
No, that's it for yourself.
Okay, thank you very much.
Yeah, let's just try to review. Make sure you're able to get what we want you to do. Not
Okay.
attack, okay?
Okay, thank you so much.
You're welcome. Normally for after each, section, I give it a small one, quiz to cover, guarantee the people follow it. See, some very easy. That's what the community interview they will be asking. They're not asking for big circuitry. I think that they talk, basically this thing you cannot do it. That means you cannot get the technician job.
That is a fair point.
Surprised you didn't comment.
On what?
Did you put the glass on the paper towel?
I didn't even see it actually.
I'm assuming this means R2.
Yes.
That will be using the current divided law.
Number 20 is number 10 is a giveaway.
That the answer?
Next time.
It can't be 20 because that's the total current. Sam is giggling. That's so easy.
I don't think that's the answer though.
Tricky question.
Yeah, right. You don't even have to calculate anything for this.
That's it.
That's it.
On that last one, since the circuit had a maximum of 20 current and 2 resistors, no way you're gonna blow that. What'd you say, Sam? That was, I looked at that, I go, man, I'm not even gonna pick up my calculator.
Can someone explain how to calculate on question number 5? I had a hard time with that one.
If also for number 10, not needing to calculate it, if you could explain to me how you didn't need to calculate it. I am brand new to this stuff, so I'd love to see the easy thing that you did or hear about the easy thing you did.
The biggest thing on that one, number 10, is resistance current takes the path of least resistance. So if you got one resistor that's 300 and another one is 200, the path of least resistance is for the one that is 200. So most of the current is going to go there, and the little bit of current is going to go to the bigger one. And then it can't be 20 because 20 was the total resistance. So how can it split up and be the same thing?
Okay, let's see. You can fill on what number? Number 5?
Correct.
Okay, I share this thing. That's number 5, right?
Correct.
Okay, so you can using the formula. Okay, let's see.
100. So let's see. 1, 2, 0, reciprocal plus 1, 2, plus.
It's on
Yeah, so
slide 29 of the handout.
The formula is like the combination is 1/100 plus 1/100 plus 1/100 is 3/100.
You get
And the
too many
reciprocal of
ways to
that
go.
is 100/3, which is 33.33.
Total equal 1. divide. I just going from basic. 1 divide R1. And you adding 1 divide R2. Then you adding 1 divide R3. That's one way. Okay, try to make it bigger. Okay, the other way, you can do this thing. You say, R1, R2 parallel, do this first. Parallel R2. Then you can get R1, 2. Okay, equal 100, 100. You know that 50 ohm. Basically, you get 100. Okay, then you can time 100. Then everything will be divide into 100 plus 100. And you know, you register the same value in parallel, then you get 50. Okay, then now you can say R3 will be parallel with R1, 2. So the formula will be equal R3 times R1, 2. Okay, and that will be divided to the R3 plus R1, 2. So which one is the answer? A, B, C, D?
B.
B. B is in boy.
B is the boy.
Right,
That means they said that answer here.
Correct.
correct.
And the other way to do it, if you look at the branch is 100 ohm on each branch. So you take 100 ohm divided by the number of branch. So there's R1, R2, R3. So there's 3 branches. So 100 divided by 3 will be 33.33 ohm.
That means too many different ways you can do.
Yeah, but when you have the same value on all the branch, that's the fastest way.
Yeah. Okay, any more questions?
That's Mr. Pham giving away stuff. He like give Christmas presents early.
Any more questions? Which
Thank
one,
you, Mr. Pham.
which one is still confusing?
Go over question 9, Mr. Brown.
9's easy.
Go with number 10, Mr. Pham.
That's easy.
But we're learning, remember.
Yeah, can we go number 9?
Okay, let's go number 9.
And then number 10.
No, we just go number 9. What's the answer?
current divider law?
For Paul Hart, yes, you are correct.
See.
Let's see, Paul, the answer you look like Hang
I
Win.
do.
Hang Win,
Gotta
you
be
are
C.
correct. Paul, you're a little bit off.
Number 10's got to be C.
Yeah.
So you want I2. So I2 equal total current,
I1 plus
I total. Okay,
time
time R1.
divide
Okay, then divide.
I1 plus R2.
Yeah, R1.
It's on slide 29 of the handout.
R2. Yeah, everything in your handout. So which answer will be right?
C.
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 Okay.
If you have 20 amps has got to divide up, and the resistance are different. So the smaller resistor would obviously get the biggest amount of amps. And 20 obviously can't be the answer. So without picking up a pencil, you can see that. Except for Sam.
Yeah, I don't see anything. Sorry.
Yeah, this is just a very basic.
Mr. Pham, can we go number 9?
Number 9, let's see.
I got a different answer.
That's number 9 here.
B.
36 times 24. Divide 36 plus
It's B.
24.
I got B.
Should be B. B.
Is it a B?
Yeah.
Right. B is correct.
Could you please go over number 8?
Number 8. Okay, they want R3. Okay, PR3. PR3 equal I square, right?
Correct.
I square time R3. Okay, which one with the right answer?
C.
C. 32 watt. So in order to do it, you have to get the current.
Current was 2 amp.
2
Okay.
amp is E squared 4.
So in other
Oh,
words,
it's
this
a
formula,
A.
you can get I equal 24 volt
divide 12.
divide to total resistance is 12. You get 2 amp, right?
Yes.
Yeah, 4 times 4 is 16, not 32.
Yes. Correct.
4 times, okay, hold
4
on.
times
Yeah, I
A.
think I got it wrong. Sorry about that.
All
Let me
right,
see.
Sam,
Yeah,
you
it should
fail.
be 16. So the answer is
16,
supposed to be
A.
A. Yes.
A, 16
Correction on
watts.
that.
So equal 2 square is 4.
4 times
Yeah.
4.
Time
Four,
R3
six.
will be 4, 16.
So 16, so A, yes.
Okay, Sam, back to Tech One.
Answer will be
I
A.
know. I'm glad to be in Tech One. It's a
okay.
good place.
You don't want to go back to school.
That's why I'm human. I have to go back to school.
Now Sam need to go back to the dinner.
That's all fun. We're all learning. We all are learning.
Well, I got my 1099 form for you, Sam.
All right, thank you.
Hey, Mr. Pham, starting next week, all the fun circuits are over with, right?
Uh-huh. Yeah, you can see basic DC very simple.
Yeah.
If you try to learning electronics, you must be get through it. At least you know what how to using the Ohm law, how to calculate the current or calculate the voltage. Okay. In the lab during this time, first thing they teach you to using MSIM7. That's the real. If you can do good and MSIM7, then you don't have a problem to do a real lab. Okay, so that will be speed you up when you start doing your real job. You get 2 days, one Tuesday and Thursday. Normally, one day will be on simulation, and another one will be on the real lab with the real equipment. In this program, we don't need to buy any textbook, and also you don't have to pay any penny. Everything will be free.
So does that mean they don't have to take out a student loan?
No.
You have to take out student loan.
If there was a book for you to suggest, what would you suggest?
Oh, I have to look in back, okay? I get 2 different books. I see which one is good. I will let you guys know. But the cost of the book is really high.
Yeah, let me go ahead and share the book that you use for the you use as your reference.
Okay, so I can stop there now
Okay.
and just stop for recording.
Okay.
I have a suggestion.